Hello and welcome to lesson 4.2, which is on analyzing graphs of polynomial functions. Today's goals are going to be to approximate zeros by graphing polynomial functions and to find extrema of polynomial functions. So hopefully the only new vocab word there for you is this one, extrema. And as a little preview for that, the extremas on this image will be here. And you guessed it, down here. Okay, so extrema is basically if something is heading upwards and it turns downwards, it's that turning point at the top, or it's a turning point at the bottom. It's where it goes from one direction, moving in one direction to the other. Okay, there's something here called the location principle I want to discuss, which is that if the value of a polynomial function, f of x, changes signs from one value of x to the next, so it goes from positive to negative, then there's a zero between those two values. This is called the location principle. Okay, so it's a pretty simple concept here. If the function at some point is negative and then at some other point is positive, well then if it continuously traveled between those points, it must have traveled through zero in the center. You can see that in the diagram below. So f of a is located in the green point. It is negative. F of b is located at the orange point and it is a positive value. Therefore, somewhere in between, we would assume we are going to have a value of 0. Okay? So, let's take a look at that key concept box. Suppose y equals f of x represents a polynomial function and a and b are two real numbers such that f of a is less than 0 and f of b is greater than 0. Then the function has at least one real 0 between a and b. Okay? So when it says at least one real 0, that means that if you've got some positive or some negative value and some positive value on a graph, then it's going to pass through 0 at least once. Well, it could pass through it more than once, right? But we know that at least it has passed through it once. Now, if on the right side we look at that think about it box, it says that not all real zeros can be found by using the location principle. Provide an example where f of a could be positive and f of b could be positive, and yet there's still a 0 in between. So let's call this a and b, and our function is positive at f of a and positive at f of b, but indeed we can find zeros in between. Okay, so the location principle is not a rule that says you will only find zeros when it goes from positive to negative between two outputs of a function, but that you will find at least one. So if there is a positive value and a negative value, you are sure to find at least one 0 in between it. That is all the location principle is saying.